This is sections 4.7 and 4.8 of Honors Algebra 2, solving polynomial equations. In order to solve a polynomial equation, we use this property called the zero product property. It says that if two numbers, a times b, equals 0 when we multiply them together, that happens if and only if a equals 0 or b equals 0. The words if and only if indicate, as you remember from geometry class, I'm sure, that it is a biconditional. That means the conditional goes both directions. So if ab equals 0, then a equals 0 or b equals 0. If a equals 0 or b equals 0, then a times b equals 0. That means when two numbers are multiplied together to be 0, one or both of them has to be 0. That is the principle we're going to be using to solve these polynomial equations. We want to be able to write them as 2 or 3 or 4 things that multiplied together equal 0. That means one of them has to be 0, and we can solve it from there. So number 1, x minus 5 times x plus 2 equals 0. We've got two things that multiply together to be 0. X minus 5 times x plus 2. Since x minus 5 times x plus 2 equals 0, it means one or both of them has to be 0. So we write x minus 5 equals 0, or x plus 2 equals 0. And the word or must be included here. It is a necessary part of this. So we solve each of those equations separately. If x minus 5 equals 0, that means x equals 5. If x plus 2 equals 0, that means x equals negative 2. We write the word or in the middle. And so our solution set is the set including negative 2 and 5. So we write brace, negative 2, comma, 5, and close the braces. Notice there's no parentheses here because these are not making a point. They are two separate values for x. So we're just listing them with a comma in between them. And that is our solution set. Number 2, 2c minus 1 times c plus 4 squared equals 0. So we have a product of things that equal 0. 2c minus 1 must equal 0, or c plus 4 squared must equal 0. Well, if 2c minus 1 equals 0, that means 2c equals 1, so c equals 1/2. If c plus 4 squared equals 0, c plus 4 squared is the same as c plus 4 times c plus 4. That means that c plus 4 equals 0, or c plus 4 equals 0. Well, those are going to give us the same answer. So we really only need to do that once. And then just note that 4 shows up, well, in this case, negative 4 shows up twice. So negative 4 is considered a double root. Each of these answers, each of these values for the variable is called a root of the equation. When it shows up twice, like negative 4 does here, it's called a double root. But we still write the solution set in the same way, negative 4, comma, 1/2. Notice I write them in increasing order, as if they were on a number line, where negative 4 would be to the left and 1/2 to the right. Number 3, y squared plus 7y equals 18. This time, I don't have a product of things that equals 0. First of all, there's no 0 at all, so we need to get a 0 in there. Then we need to write the rest of it as a product of things that equals 0. So let's get a 0 by moving everything to the left side. We'll move the 18 over. So we have y squared plus 7y minus 18 equals 0. And we've got a 0 on the right side. So what we want to do is take the left-hand side, the y squared plus 7y minus 18, and rewrite it as a product of things that equal 0. Well, we can do that if we can factor the left-hand side. And we know how to factor that. We look for two things whose product is negative 18 and whose sum is 7. Well, how about positive 9 and negative 2? We'd have y plus 9 and y minus 2. 9 times negative 2 is negative 18. 9 plus negative 2 is positive 7. So we've got it in factored form, and then we can break it up and say y plus 9 equals 0, or y minus 2 equals 0. So we had to get it so that we had a product of things equal to 0, and then we can break it up and solve it from there. So that means y equals negative 9 or y equals 2. So our solution set, negative 9, comma 2. Number 4, x squared equals x plus 30. So again, we want 0 on one side, so let's take everything to the left side. X squared minus x minus 30 equals 0. We factor the left side. Two things that multiply together to give us negative 30 that add together to give us negative 1. How about negative 6 and positive 5? So x minus 6 times x plus 5 equals 0. It means x minus 6 equals 0, or x plus 5 equals 0. So x equals 6, or x equals negative 5. So our solution set is negative 5, comma 6. Number 5, 3x cubed equals 4x times 2x minus 1. Alright, well let's get everything to the left side. So 3x cubed minus, now this is all one unit right now, 4x times 2x minus 1. That equals 0. So it was positive on the right-hand side. I move it to the left side by making it negative. Even though the 4x is multiplied by the 2x minus 1, I don't have the whole left-hand side as a product of things because that 3x cubed is not multiplied by the 4x and the 2x minus 1. So what I need to do is distribute the negative 4x, and then I'm going to refactor the whole left-hand side. So I'll have negative 4x times positive 2x is negative 8x squared, and negative 4x times negative 1 is positive 4x. Now I'm going to factor the left-hand side. I look for a greatest common factor between all of those terms, and all of them have an x, so I can take that x out, which will leave me with 3x squared minus 8x plus 4 equals 0. And then I want to factor what is in parentheses. So remember, I take the 3 times the 4, and that's 12, and I look for factors of 12 that will add together to give me negative 8. So maybe negative 6 and negative 2. Their product would be positive 12, and their sum would be negative 8. So then I divide one of those by 3, because that's my leading coefficient. So I divide the negative 6 by 3, and I get negative 2. So I'll have 3x and x. So that 3x times x is 3x squared. I got a negative 2 when I divided by 3, so that has to go opposite the 3, and then the other negative 2 is going to go there. If you don't remember that, look back at your notes from the previous video. So you've got x times 3x minus 2 times x minus 2 equals 0. Now I've got a product of 3 things that equal 0, so I'm going to have 3 equations equal to 0. X equals 0, or 3x minus 2 equals 0, or x minus 2 equals 0. So x equals 0 is already solved. 3x minus 2 equals 0 means 3x equals 2, and x equals 2/3. X minus 2 equals 0 means x equals 2. So my solution set includes all 3 of those things: 0, 2/3, and 2. There are 3 different values for x that would make that equation true. Let's look at this from a function perspective. A 0 of a function is a number in the domain which makes the function equal to 0. So a number in the domain that corresponds to 0 in the range. There could be more than one number in the domain that corresponds to 0. So, for example, find the zeros of f of x equals 2x minus 3 times x plus 2. If I want to find the zeros, those are going to be the numbers for x that make the function equal to 0. So if I want the function equal to 0, I'm going to write it as 0 equals 2x minus 3 times x plus 2. And this is no different from what we've just been doing. We've got a product of things that equals 0. So that means we break it up. 2x minus 3 equals 0, or x plus 2 equals 0. If 2x minus 3 equals 0, that means 2x equals 3, and x equals 3 over 2. Or if x plus 2 equals 0, that means x equals negative 2. So my solution set is negative 2, 3 over 2. That means in terms of the function, f of negative 2 must be 0, and f of 3 over 2 must be 0. Those are the zeros of the function. So the zeros of f are negative 2 and 3/2. How about a word problem? An artist is designing a poster that consists of a rectangular print with a uniform border. That means the border is the same all the way around. The print is to be twice as tall as it is wide, and the border is to be 3 inches wide. If the area of the poster is to be 680 square inches, find the dimensions of the print. So of the actual artwork. Well, let's follow the 4 steps of the problem-solving process. Number 1, let's define a variable, and I think we can do it with just one variable here. Let's let W be the width of the print. Why do I not need to let L be the length of the print? Because we can actually write the length in terms of the width. If W is the width, that means since the print is to be twice as tall as it is wide, 2W is the length. So the width is W, the length is 2W. So now, step 2, let's organize the information. Let's do that in the form of a picture. So we've got the print itself, which is a rectangle with a width of W, a length or a height in this case of 2W, and we have a border that goes around the print. The border is another rectangle where the gap between the edge of the border and the edge of the print is 3 inches all the way around. So this is 3 inches, this is 3 inches, this is 3 inches, and this is 3 inches. Okay, now we know the area of the whole poster, which is the border with the print itself, is 680 square inches. That whole poster is a rectangle. How do we find the area of a rectangle? We take the length times the width. So we can write an equation or an expression for the width and expression for the length. The width is going to be W plus the 3 that's on the left and the 3 that's on the right. So W plus 6. The length, or in this case the height of the whole poster, is the 2W plus the 3 that's on the top plus the 3 that's on the bottom. So 2W plus 6. Then this whole thing is a rectangle, the area of which is the length times the width. So the area of this poster, which we can write out as an equation, is A equals 2W plus 6 times W plus 6, the length times the width. We know this area is 680 square inches. So we can replace A with 680. 680 equals 2W plus 6 times W plus 6. Now we have the right-hand side factored out, but it's not equal to 0. So we need to get it equal to 0, so we need to move the 680 over to the right-hand side. That will give us a 0 on the left-hand side, so 0 equals 2W plus 6 times W plus 6 minus 680. And now the right-hand side is no longer factored. So we need to FOIL out the 2W plus 6 times the W plus 6. This, by the way, is all part of step 3 of solving the equation. So we're going to FOIL out 2W plus 6 times W plus 6 and then refactor that whole right-hand side. So when we FOIL it out, we get 2W squared plus 12W plus 6W is plus 18W plus 36 minus 680. We can then combine the 36 and the negative 680, so 0 equals 2W squared plus 18W. And then 36 minus 680 is 644. And now when I'm factoring the right-hand side, I notice that it has the greatest common factor of 2, and I can divide everything by 2. So I'll have 0 equals W squared plus 9W minus 322. Now how do I know I can just divide everything by 2 instead of having to factor out the 2 and write it in front? Because I now have an equation with a 0 on the other side, and I can divide both sides by 2, and 0 divided by 2 is just 0. Okay, so now we can factor the right-hand side. So I need two numbers that multiply together to give me negative 322, but add together to give me 9. Well, how about negative 14, and positive 23. Sounds good. So 0 equals w minus 14 times w plus 23. That means w minus 14 equals 0, or w plus 23 equals 0. If w minus 14 equals 0, that means w equals 14. Or if w plus 23 equals 0, that means w equals negative 23. So now, in step 4, where we're answering the question, we're going to narrow this down from 2 numbers to only 1 number. And we can do that because if we think about the problem, we have a width for w, and that width can't be negative. So this w equals negative 23 doesn't work for this problem. And that's okay because we have the word or. And here's where the word or is crucially important. We don't need both of them to work. We only need one of them to work. We'll take the one that does work in the context of the problem. W equals 14. So when we answer the question in step number 4, and the question was to find the dimensions of the print, we're going to write the width of the print is 14 inches. The length, which is 2 times the width, 2 times 14, is 28 inches. Now we've answered the question. Number 8. A batter hits a baseball directly upward with the speed of 96 feet per second. Part A, how long is the ball in the air before being caught by the catcher? And part B, how high does the ball go? We can answer this by setting up an equation using one of these formulas for vertical motion. H equals v times t minus 4.9 t squared if the distance is measured in meters, and h equals vt times minus 16 t squared if the distance is measured in feet. You may or may not have seen those in physics class. Those 4.9 and 16 are the only differences between those two equations, and those come from the acceleration due to gravity. So, we have feet per second, so we're going to use the first one. H equals vt minus, or the second one I mean, vt minus 16 t squared, because our distance is measured in feet. Part A asks, how long is the ball in the air before being caught by the catcher? So the ball is going to be hit, goes straight up, turn around, come back down. How much time is it going to take for the ball, after it's hit, to go up and come back down? When it comes back down, what height is it going to be at? Well, it's going to be at ground level. It's going to be at a height of 0. So what we're essentially asking in part A is, what is the time that it takes for the ball to be at height 0. That's where the catcher is at ground level, is height 0. H is the height. So we're going to say 0 equals vt minus 16t squared. We're making the height, h, be 0. But we know what v is. V is the speed, which is 96 here. So 0 equals 96t minus 16t squared. And this is a quadratic equation because the highest power of the variable t is 2. So we can factor the right-hand side. So we look for a greatest common factor of 96t and negative 16t squared, and that greatest common factor is 16t, because 16 does divide evenly into 96. So we'll have 16t times 96 divided by 16 is 6. So we'll have 6 minus t, because t squared divided by t is t. So we factored out the greatest common factor of 16t. Now we've got two things that multiply together to be 0, so 16t equals 0, or 6 minus t equals 0. If 16t equals 0, you divide both sides by 16, that means t equals 0 divided by 16, which is just 0. Or if 6 minus t equals 0, that means negative t equals negative 6, so t equals 6. T here is measured in seconds because our speed was in feet per second, so this is 6 seconds and 0 seconds. Now those are two different numbers for x. Both of them are non-negative, so we don't have to worry about negative times, but there are actually two times at which the height is 0. When it's first hit, which is 0 seconds, and then when it goes up and comes back down, and that is 6 seconds. So what we're really interested in here is the 6 seconds. Because we know at 0 seconds it's going to be at a height of 0. We're interested in the 6 seconds, which is how long it takes to go up and come back down. So 6 seconds. Now part B, it asks, how high does the ball go? So what is the height at the top where it turns around and comes back down? Well, the great thing about this is that gravity affects the ball the same way going up as it does going down. So it actually is going to be halfway in terms of the time as to when the ball turns around and comes back down. It takes 6 seconds total. It means it spent 3 seconds going up and 3 seconds going down. So what we are really asking in part B is, what is the height when t equals 3? So at 3 seconds, what is that height? What is that point at which the ball is turning around? So we're going to take our equation, h equals 96t minus 16t squared. And we're going to let t equal 3. So h equals 96 times 3 minus 16 times 3 squared. So 96 times 3 minus 16 times 9 is 144. So h equals 144 feet, because our speed was measured in feet per second. So at that height, where it turns around, it is 144 feet. Here are your immediate practice problems, modeled after the examples I did at the beginning. Solve the equation. Number 1, 3x squared minus 10x minus 8 equals 0. So just factor the left-hand side. Number 2, t squared plus 25 equals 10t. So move the 10t over to the left side first and then factor. Number 3, x minus 2 squared times x minus 9 equals 0. So it's already factored. And that is the end of sections 4.7 and 4.8.